They have a bus.
They do have a bus.
3-4, ladies and gentlemen, 3-4.
All right, here's it.
No, 3-3. 3-3, ladies and gentlemen. Sorry, 3-3. Today, we are doing properties of logarithms. Properties of logarithms. Okay. Some of the lesson you've already learned last time. I talked to you about it. Okay, like this. What did we do to solve that? Because once again, that's 2 to the x equals 5, correct? If I change it as an exponential, could I get them to be like bases, 2 and 5? No. No, you didn't figure it out. You got close. Then you didn't get it. You said, I got it exactly. What did you get every decimal? Let's see. Put it in your machine. Pull it out. It's your fault. Shut up.
You gotta run out your car right now.
So for many of you, because you have the TI-84, what calculator do you have? I'm just checking. Oh, you have an 84. So since you weren't here, I'm going to do it just for you. So here's our calculator. Remember, we would go alpha, window, alpha, window. Number 5. Notice it's not very large right now, but what's my base that I can put there? What was it? A 2. Did you have the alpha window go down to log base? 2, 5, 2.321928. Did you get all that? No.
Yes, I did.
Got that?
Make yours worthwhile.
Oh, I don't believe you. You're a liar. Liar, liar, pants on fire. Okay, change of base. I'd like to get this lesson done in 20 minutes. Because it should be pretty simple. Everyone time me? Yeah. Okay, put it on the timer. We're going to see where we're at. And I'm not going to go speedily fast. Tell me when we're starting it. Ready, set, go. Okay. So remember, last time we talked about change of base, because who had an 83 or a different kind of calculator wasn't able to, and some of you, right? How did we do change of base? So we do the common log, where I did log, because that's on our calculator is the log button, our common log. Or we did what else? The natural log style. Okay, and if I put those both in my calculator, would I get the same result as what I did when I did the log base 205? I would. This is called change of base. Now, what if I said, please change the base? Please change the base to base 7. How would I do that? That's log base 7 of 5 over log base 7 of 2. Now remember, the change of base formula tells us to do what? It can be any base. It just has to be the same base when I do it. Now, why did I personally show you guys these two last time? Because those are the buttons on your calculator. Right? The log and the ln are on our calculator. No, I don't know how to do that without it. I mean, like we said, we could get close. We could get close. Shut your pie hole. I'm not ashamed. I'm on a dot of shame. No. I'm down. If you're on my list today. By the way, did anybody by chance do running? Nice. Did you? Are you a cross country guy? Okay. Anyway, so some people asked me as I was teaching this today, they're like, Mr. Roberts, oh snap. Napper, here we go. They asked me, Mr. Roberts, why would I ever do this? Sometimes it's nice to change it to any base I want. Here's an example. Log base 16 of a fourth. I can show you the first way that you guys probably would know how to do what you kind of learned the other day. Okay, let's go ahead and make that x, and let's change this to an exponential. What is this as an exponential? 16 to the x equals 1/4. Now I say to myself, can I get these guys to be the same base? Yes. 16 is the same thing as 4 squared, right? Oops, x. 1/4 is the same thing as 4 to the -1. Because remember, he's downstairs. If they're like bases, hold on, first off, power to a power, we have to multiply. But if they're like bases, don't these guys equal each other? Right? So therefore, 2x equals -1, or x equals -1/2. I'm going to show you, in my opinion, it's 2 raised to the x. I personally am going to show you a quicker way, in my opinion. I'm going to change the base on this. Notice I changed it to base 4 because that's what base both of them can become. Right? What is log base 4 of 1/4? 4 to what power is 1/4? -1. 4 to what power is 16? 2. -1. Notice by changing the base to a common base, that allowed me to do that a lot quicker than the same result over here. Right? Could I have also did that log base 2? Because 1/4 and 16 is below close to go to. We could also go to base 2 because 1/4 is 2 to the -2. 16 is 2 to the 4th. Right? Yes. Because remember, 4 to what power is 4? 1. But because he's downstairs, -1. Because remember, anything with a negative exponent jumps the line. Remember that? You must have not been there that day. Because I've been saying jump the line, change the sign, have I not? Yeah. No? I don't care. It's losing your brain. Is that what you needed? Yeah. This is not counting part of my content. No, keep it going.
I did.
Good? Onward. Okay. That's really stuff that we've already learned in the past. Okay. Might not. But today, we also talked about, as we said last time, what is a logarithm? It is the inverse of a exponential. So some of the things that work in exponentials kind of work in logarithms. For example, x to the m times x to the n. What is that? X to the, is it mn? M plus n. Notice if I have x squared times x to the 7th, I add 2 and 7 to be x to the 9th. Remember, I add when they're like bases. What happens when I divide? Subtract. Right? What happens when I do a power to a power? Multiply. These are all rules that I should know how to do, correct? Any questions there? Okay, now how does that work in logarithms? Well, let's go to logarithms. Sounds everybody good? Okay, here we go. So if I had log base A of B times C, I see multiplication. When I saw multiplication last time, what did I do to the exponents? I added them. So I am adding them. Okay? Those are our bases of A. If I have division, what did I do on the other one? I subtracted. So what am I going to do here? I'm going to go log base A of B minus log base A of C. Okay. What do you guys think of log base A of B to the C? Multiply. So what it's going to be is C times, or it's just C log, right, of A of B. That C gets pulled out front. I'm not sure. It's just multiply, you bring it out and multiply your logarithm by that power. I'm going to show you in just a second why it works, and you'll make your own. Okay. Would you guys agree? Sorry, I'm going a little quick. Got to get my 20 minutes in. How do you guys keep up? Get that hand going. Okay. So what is, using that last rule I just said, what's another way I could write log of x to the third? 3 log of x. Okay? Would you guys agree that would be the answer from what I just showed you? Okay, let me show you why it kind of makes sense then that it comes out that way. What's another way to write x cubed? Okay, so another way to write it is x times x times x. What do I see there though? I see multiplication, huh? What do I do with multiplication? Addition, so that's log of x plus log of x plus log of x. How many log of x's do I have? Because that power is repeated multiplication, right? And multiplication is addition in logarithms. And what is repeated addition? Multiply. You with me? I would also like you to think about this. What about y? Your phone is not my friend. Okay. What about x over y? What's another way I could write x over y? Log of x times y to the negative 1. Is that not the same thing? What do I see here? Multiplication, right? So I have log of x plus log of y to the negative 1. But what do I do with that negative 1 power? Multiplication, right? Do it as a multiplication. What's positive 1 times a negative 1? And it's why we also I'm just showing you multiple ways of thinking of it. Good. You didn't get to see any of the cool examples, but you got through at least the problem. Is ready to rock now?
20 steps.
Huh?
20 steps, right?
20 steps. 20 steps after you leave the room. Should I go check? No, that's 20 minutes. 20 minutes. Okay, here we go. So, today our goal, ladies and gentlemen, is to expand logarithms or condense logarithms. Meaning, we did expansion when we had the a times the b, right? That's expanding when we went from one logarithm to multiple logarithms. Does that make sense? Bye-bye. See you. Have a good day. Bye. So, let's go with this guy. We are going to expand this. So there's multiple things in there, isn't there? I have powers, I have multiplying, I have division. Right? What's a way I could write this? Well, my first thing I see is the division. Whenever I see division, I go there first. So I'm at log. Now notice I'm just doing logs right now because I don't want to write this base every time. So this can only work if they're like bases. I'll show you like when I condense it, they have to be like. So if I have an ln and a log, I can't do those because they're not like. Does that make sense? Okay. So this is log x squared y squared minus log of z cubed, because the division is the subtraction, right? Okay, but what do we see in this guy? Multiplication, right?
Yeah.
You want to go there first. So that's log of x squared plus log of y squared minus log of z cubed. Am I done? What's the last thing I got to do? Bring out all the powers, right? So all the powers would be what? 2 log of x plus 2 log of y minus 3 log of z. That is an full expansion of that log. Was it? You think?
Yeah, it's not
Did you show her the rules?
Oh, yeah.
How old's your little sister? Okay, well, first off, they're not ready. Could you teach an eighth grader this? Okay, good. Okay, this time I'm going to have you guys go ahead and try one yourself. Ready, set, pause. This guy right here is the right one. Let me explain one. You need to do it up here. So the first thing that I do is I do the division, just like you guys did, right? Okay, but the key thing here is this one little thing. This is this whole thing minus this whole thing. So when I see this, this is minus parentheses log of y plus log of z, right? Does that make sense? What do you need to do with that minus sign? That's the biggest thing. Because what you guys are saying, well, these two are multiplying, Mr. Roberts, right? That's what you're seeing. But it's, yes, those two are being multiplied within that division. Does that make sense? So do you guys ever understand how Chuck has it by distributing that through to both of them to get the both minuses? Let me show you another reason why. X over y over z is the same thing as x over y z. So I could do this division, and then that division again, and that's how you do it. Okay? Let me show you. Yes, another way that, like I showed you guys earlier, what's another way I could write this? Log of x, y to the -1, z to the -1. So couldn't they both be negative when I bring down those powers? Does that also explain why they both should be negative? Because their powers are negative? If you really think about it. You with me on that? Okay. Does that help out? I purposely did that one to let you try because I wanted you guys to see that it's important to understand anything on the bottom is going to have a negative in front of it because it's okay. Any questions? Okay, next one. We're going to now condense. This is the very most basic you could really use here. I'm getting close to my 20 minutes, huh? We're not going to make it quite. We're going to close, but not quite. What do you guys think this would be? Log x cubed, because the 3 comes up, right? Over y. Anything that's a minus is going to go downstairs. Anything a positive will be upstairs. Okay? How are we doing? Good. You guys okay? Denise, you okay? All right, so we do the last one. Yep.
Always do this one.
No. We're going to do ln. This is condensing. This is almost. Ooh, that sounds good. Okay, what do you guys want to do first, do you think? What do you think, Wyatt? That could be both. Brackets and apprenticing mean the same thing in when you're putting them in a problem. Not when they're doing like domain and range, but when they're doing this. Distribute, good. So what's a third times 3? 1. Just 1, so I have ln of x plus 2/3 ln of y minus 6 ln of z. Here, though, here's 2. He's not an ln. I want him to be an ln because I want to condense down to everything in one logarithm. What's a way that I could write 2 as a ln? A little bit thinking you got to think with. Think about this. I'm saying ln of what equals 2. Basically, that's what I'm trying to find, right? What goes in that lovely question mark? What's our base? E, because it's ln this time. So this is E. So E squared is my question mark, right? Plus ln of E squared. Does that make sense to everybody? How 2 is the same thing as ln of E squared? Really quick, let's go off subject really quick. So if I said I want it to be base 5, what is 3 as base 5? Once again, do a little formula. Right? What goes there that would make this equal to 3 as a logarithm? 5 to the third is 125. So, see how I do that? So, with that being the case, I'm going to bring up right here, guys. I don't even do the next step. Yes, sorry. So it's not ln of E squared. Notice this was a 2. So I'm wondering, how can I make 2 with ln of base E, because it's really base E right there, right? To be what goes here to make that work. To make E equal to 2. Well, E squared goes right there. Remember, if this base and this base are the same, what's your answer? That makes sense? Okay. Awesome. So let's try and condense this. From here to here. Distribute it. Does that make sense? I understand how it's a 30, how you can see that. Everything else still good? Now, guys, do we all understand everything out front is just going to become a power on all these? Okay, here we go. This is what I do. I go ln. Who goes on top? Anything that's positive. So x is going to go on top. Who else is going to go on top? Y to the 2/3. And who else? And E squared. Those guys are all positive. Right? Who's going to go on the bottom? Z to the 6. They might have that y to the 2/3 as the cube root of y squared. You never know. They might have it that way. Okay? So understand you might have to put those as back into a radical. That's all, that's really as hard as you're getting today. That's one of the hard ones. Okay? Going back once again, here's your homework. Most of you guys have written it down. You have 20 minutes, or 15 minutes, 17 minutes, if you want to do any work. There you go.